regions.
I hope you don't mind that I recorded, Larry.
No, that's all right. No worries. These sunspot regions are areas of the sun that emit radiation that our ionosphere picks up. Think of our ionosphere as a negative part of a battery, and those sunspots as the positive polarity of a battery. They're coming towards Earth. Now, the issue when you talk about radiation coming from the sun is, where does it go? Okay. If the geomagnetic field on Earth is pointed south, okay, like it is during the winter time for the most part, you have what's called a negative BZ latitude. Okay. And what that means is the Earth's geomagnetic field is pointed towards the South Pole. That can cause things like a full propagation blackout on HF. It can cause noise floors to skyrocket, or both. Okay. But we need those sunspots to charge up the ionosphere. This is what's part of the solar cycle. We're at the beginning of solar cycle 25. And I honestly think 25 is going to be really, really good. I think it's going to be one of the better sunspot cycles we've had. Early indications have been brilliant. We're in triple digits for SFI numbers, which is the solar flux index. Sunspot numbers have been pretty good for the first year and a half into into this sunspot cycle coming up, which is roughly about 4.5 to 5 years. So we're in a good spot right now. This is today's A1A. Okay, so there's the sunspot regions. You see a bunch of bright spots in the top, as well as some on the bottom. Okay, we also have Earth has a satellite that's in a geostationary orbit on the back of the sun. Okay, and this is what that looks like today. Okay, there are 5 sunspot regions currently on the backside of the sun. Those regions will slowly come around if they survive, and will come back to the front sometime next week. Okay, and they'll help to continue to charge up by our ionosphere. One of the things we have to be careful for are coronal mass ejections, and those come from the most part from coronal holes. So we monitor coronal holes. This is today coronal hole map. This is the one for today. There's 3 that are active: 51, 52, and 49. Okay. And the radiation from those is going to be, for the most part, pure plasma, okay, as it comes towards the Earth. When we have a negative BZ latitude like we have this evening, it's going to have a problem with our propagation. It's going to cause noise floors to go up, and it can cause propagation to be very, very bad, especially on the lower frequencies where the D layer, because it's so attenuating, for daytime frequencies, it charges up the D layer the most. The sun always charges up the D layer the most. And so because of that, the D layer is most affected by solar storms. So when we look at the QRZ, for example, you take a look at this picture shows that the SFI in the top left is 127, which is a good number. It really is, especially for this part of the solar cycle. Solar number is 75, and that's actually a formula. It's not the amount of sunspots, but it's the amount of sunspot groups and sunspots combined. So 75 is that formula number. The A index is something we watch carefully. That's the radiation from the sun. Okay. A is radiation from the sun. K is radiation from the planets. Okay. Because the planets all have an impact on our magnetic field. All the planets do as well. When the A index, as you see at the top left up here, A is 27, we like to see a number 10 or less. Okay, 10 or less is a great number for us because it means it's a pretty stable stream of radiation coming from the sun. When we get a higher number, it's a lot more charge from the sun, and it tends to jolt our ionosphere. So it doesn't give us real smooth conditions on the bands. So if we look at the conditions right now, the radiation from the sun, 27, K, 3, and 3 means unsettled. The K index is something we all pay attention to because that's our noise floors. You folks in CW, this is really important because you're listening to many times very weak signals coming from halfway or farther around the world. And you may say, well, how could you get farther than halfway? Go halfway around the world and then go due south. Okay. You'll get halfway more. Those signals can come from a long, long ways away. And when you're dealing with those weak signals, The noise floor makes a huge difference in your ability to hear them. Okay. So when we talk K groups, we're in threes. Okay. There's K1, 2, and 3, K0 through 4. And then you have K5, 6, and 7, K8, 9, and 10. It doesn't go higher than 10. We worry when we get above a K4. K4 is we're in a geostorm. Okay. K5 is a minor storm. K6 is a major storm. You get to K7 and higher, you're talking about HF blackout. All right. So we've just experienced K6. That was yesterday, or sorry, earlier today, UTC. It went back down then to K5. Then we went to K4, and we've kind of been at K3 the last 3, 6, 9 hours. So the last 9 hours we've been at K3. That's an unsettled K index, but at least it's not active. Okay. Earlier today, I'll give you a good example. When I was on the bands earlier today, I was talking on a group that's called the HF activity group. Okay. And this was the way that the conditions were. This is at 1809 GMT. SFI was 128. The A index was only 12. Okay. But look at the K was 4. That's higher. Now, when you look down below where all the HF band conditions next to the round sun there on the left, it says geomag field active. Okay. When you reach a K4, it's active. When you reach a K3, like we are currently this evening, I'm going to change the slide. K3 is unsettled. Okay. An active K index, what that does is take a look at the HF band conditions, what it does to them. And you can see that right beside that red sun there to the left. Okay. HF conditions. And you're probably very familiar with this. It says HF conditions band 80 through 40, 30 through 20, 17 through 15, 12 through 10. Everything's either poor or fair. Okay. And that's simply because you've got a K index of 4. You're right in the middle of a geomagnetic activity. Within an hour and a half later, I did another test to see where we were at. The A index was 12, but the K had dropped 1 to 3. And look at how the HF conditions changed. 80 to 40 were still poor and fair as they were earlier. See, they were poor and fair. But look at the upper bands. 30 and 20 were good. 17 and 15, good. 12 and 10, fair and poor, where before everything was either poor or fair. The K index has a huge difference. Sorry, wrong slide. K index has a huge difference in determining the type of calls that we can make, as does the A index. What we're hoping for when we really look at all these numbers, we'd like to see an A index under 10, a K index under 3. We'd like to see the BZ latitude positive. Okay. If you look below the first group of numbers, it's up here. There it says the month 03 February 22. Below that is SFI. Below that is A. And you go down that line of first columns, right? The last one is BZ. That means the Earth's geomagnetic field is currently pointed 1.0 degrees positive towards the north. Okay. Barely towards the north. Excuse me. The solar wind is something we do pay attention to. We want it to be below 500 kilometers per second. Okay, that's 544.6 kilometers per second, but it's not bad. When you have K index of K4, you have active conditions. And what this means is your signal to noise level, you're going to have a signal level of S3 or S4 to go above the noise. Does that make sense? So that means the calls you're going to be able to receive must be an S3 to S4 for you to hear them, whether they be Morse code, RTTY, FT8, or they be, a sideband. You have to have a higher signal to noise ratio. So when we're in the middle of a geomagnetic storm, it makes a huge difference. And that's what happened because we had an M-class flare that happened 3 days ago, okay, from the sun. 3 days ago, I always look at solar flare detection. And 3 days ago, we had an M1.1 flare. That's a pretty big flare. The only one that's bigger is an X-class flare, which is, which is 10 times the power of an M-class flare, and a proton flare, which is the highest of all, which is 10 times more than 10 times more than 10 times more. Okay. It's really bad. You don't want that. So we've been pretty much plugging along at C-class flares for the last 2.5 days. But that M-class flare that hit 3 days ago is what's causing the conditions to do this. Okay. And that's why our HF bands have been really noisy today. Very, very noisy. When I tried to work earlier today on 15, 17, 12, and 10, there was a lot of sizzle. Usually you hear it that way. It's like a sizzling sound versus just static. Okay. That's the sound of a geomag storm. The sizzle versus static is the sound of a geomag storm. So you have to kind of understand. And something I can't stress enough to you from too many years in commercial broadcasting, I want to say this to each and every one of you. And if you remember one thing I tell you tonight, this is what I want you to remember. It has nothing to do with space weather. When you keep your headphones at a reasonable level, you'll keep your hearing a long time. But what happens is too many hams over the years turn their headphones up too much because they want to hear the calls really bad and the volume's too high. Their hearing starts to go bad, and then they lose their hearing later on in life. They're with hearing aids and they have a lot of problems. It's not worth making the call by ruining your hearing. Please understand that. I mean, one of the things every program director I ever worked for in commercial broadcasting told me the same thing. Keep the cans low, keep the ears long. And I can't stress that enough to you guys. Make sure that you don't risk your hearing because you want to hear that one rare ZL call or that ZS call from a South African station. There'll be another day to make that call. Okay. But space weather is important. We look at A, we look at K, we look at the BZ latitude and the solar wind, and we want to see what the noise floors are doing for signal to noise ratio. Those things help us. They really do. Beyond that, it really, the proton flux, electron flux, and the aurora, something to look at for the aurora, if you like to work the aurora, is take a look at the aurora latitude. If it shows up in red, you're going to be pretty far north above the Arctic Circle to work it. Okay. But once it starts going green, yeah, you can work the aurora if that's what you want to do. But for the most part, I focus on the SFI, the true solar number, the AK, BZ latitude, and the solar wind. And I can pretty much from there get a pretty good idea if HF conditions are pretty good or if they're going to be pretty bad. Like today was pretty spotty.
So I'm just looking at the current conditions, Larry, and the A index is clear up to 27. K's down to 3, but the BZ's dropped to -3.
Yep. And that's where it is. And see, here's where it was at 0109. Okay. At 0109, A was 27. K was 3. BZ latitude at that point was -1.3, and the solar wind 564.2. As that BZ latitude points south, okay, as it starts to go south further, okay, and as the solar wind increases, conditions will deteriorate even more. They really will. You'll have HF. I don't yawn over there. Okay. I see you. Don't do that. Okay. I'll have to get the bad CQ guy on you. No, I'm kidding you. This is a tough subject because I don't want it to be dry. I really don't. Everything we do on HF works off the sun. Okay. If you're doing VHF, UHF, doesn't matter. You can have a crummy sun, doesn't matter. But for 3 to 30 megahertz, the sun makes all the difference in the world. And keep in mind, guys, when HF was first discovered at the turn of the 20th century, they didn't want it. The governments around the world thought it was worthless. They didn't understand how it worked. But because of really smart guys like Marconi and Tesla, who really did a lot of testing to figure out how it worked off the ionosphere, we've got a gem of a hobby here. Okay. But we just have to know how to use it right and when to use it a certain way. So like today, the higher frequency bands are going to work better than the lower ones are because there's going to be so much noise on, say, 80 and 40 meters. Even for a winter night, 80 is usually pretty quiet, right? Because there's not a lot of thunderstorms and electrical storms all over. Tonight, it's going to be pretty loud because of the way that the K index is. Yeah, really loud. In fact, let me take a look. I'll show you real quick on my radio. currently what it sounds like, just to give you an idea on 40 meters, because I'd been on previously, and it was a pretty loud evening. So for 40, excuse
My
me, I'm
noise
sorry.
floor's at S7 right now on 40.
What's that?
My noise floor's at S7 right now on 40.
Yeah, it's pretty quiet. It's pretty loud. It's pretty loud. Let me show you real quick. I'm going to show you 20, third. This is 75, 80 meters. So 80 meters in the US. And this is with just typical RF gain right now. This is 75, 80. Let me get you right to it. Here it is. This is right now 75, 80 meters. Look at that. It's an S6. That means for you to be able to pick up a CW call, it better be really loud, like an S7 or better, for you to be able to make that call, because your noise floor right now is about an S6. So when you have things like this, it's when space weather really makes a difference. You see slides like this, you see why it says 80 meters in particular is going to be poor during the day and fair at night. That's why it looks that way. Now, to be fair, the conditions are pretty accurate today. Before we did this meeting, I was able to make a call to Hawaii, to Alaska, to Mexico, no problem whatsoever. But they were all on 20 meters and higher. Okay, so that's the reason why, the higher bands, if you look here, they're not affected like the lower bands are by a high K index. K index is really strongly affecting on those lower frequency bands of 10 megahertz down. And that also includes, by the way, for people that like to DX, shortwave, and the AM DX band too. If you like the medium wave DX stuff, it'll affect that too on 300 meters too.
Cool. Frank, did you have any other questions about some of the medium wave frequencies and the?
Well, we don't have to get into it too much. I mentioned to Greg that I'm active on 630 meters,
Mm-hmm.
which is below the AM broadcast band, and
So you're a low frequency guy.
yeah, and
Long
generally,
wave.
my experience is that what's good for the high bands, like 10 meters, is bad for the like long wave bands, and vice versa.
Yes.
So those guys like solar minimums, and the idea of a new solar cycle and a lot of activity doesn't give them a lot of joy. So
No. I think, you know what? I think what your name was, Mike. Is that it?
oh, it's Frank.
Frank, I'm sorry. Frank, bear with me. I'm sorry. No, even with a higher solar cycle, we're still going to do well, even with long wave. And I wish more long wave was still here. You look a lot younger than I am, so this is my 50th year DXing shortwave and long wave stuff. So back in the 60s and 70s, I remember in the 70s there were a lot of long wave stations you could hear, especially running from Europe, but now there just isn't that many anymore. You could still work a lot of long wave stuff, and the solar, as we hit the solar maximums, it will make a difference, because it does bounce off the ionosphere. It really does. Same stuff. You're not going to, that ionosphere needs to be charged, and as we get more sunspots, it's going to get better. You're going to start hearing more of that BBC again on long wave. You will.
All right. Anybody
Yeah.
got any other
You will.
questions?
Yeah, keep in mind, guys, I don't
Don-
want to make this to be boring as crud to you.
Don's
'cause
got a question. Go ahead, Don.
Oh, go ahead. Sorry.
You're muted, Don.
Unmute.
There you go.
There you go.
Okay,
Hi, Doug.
so, hi.
Hi, Don. How are you? Victor
Larry.
Alpha 3 Bravo Union Foxtrot. I like the call sign.
We're in Canada. The daughter, she's about 4 hours north of us. They had northern lights last night. But so with regards to magnitude and velocity, Carrington effect, M class, X class, what do we got to do to get another one of these? Not that we
Are you
want
talking
one.
about for really low northern lights?
No, I'm talking about how is there a possibility? What are the conditions that you need to get a Carrington effect?
I'm not familiar with that, so I don't know. Yeah, I
Okay.
can't tell you that. Yeah, I'd be guessing. Like I told Greg, I'm a pretty simple guy when it comes to weather. I pay more attention to stuff where people are going to be dealing with HF issues in terms of propagation and what that's going to be like. And thankfully I've learned a little bit about over the years, like today, geez, it was funny. The lower bands, 2017, terrible, terrible. But once you approached 10, when it was barely there, you could make calls right in South America. I mean, it was just phenomenal, but you couldn't make them to the East Coast. It was just an odd day. That's what disruptions do like this. So it's very directional. And a good key is to look at your MUF map. If you've got a good MUF map you like to look at, pay attention to it, because it's going to make a big impact on where you're going to work, even with crummy conditions. And to give you an idea, this one changes every 15 minutes. Earlier today, when I made the call I was making earlier, this was the conditions. And I literally worked, I think it was Mexico City, XE1 DJL. And if you take a look at the Northwest here, it was just right there around 26 megahertz. But I made the call at, what was that? I was on 24.9. So I was right there on 12. And it shot straight down into Mexico when we were both 5.9 strong, but the conditions permitted that. So, a space weather thing really helps when you get the A index below 10, K is below 3, and you have a solar wind, a BZ latitudes, that's positive. And that's going to be a lot of tests. When you get to like some general questions, a lot of extra questions in the US have to do with BZ latitude. Negative BZ latitude is really bad for HF.
So one clarifying question on that for me, is it really bad for HF all over the world or mostly in the Northern Hemisphere?
All over the world.
Okay.
Yeah, all over the world. Yeah, and it'll be that way. And what you see is when you see, like, for example, it's a good question, Greg, when you see things like this, when you see an A index is elevated, okay, not the K, but the A, when the A goes up like this, like right now, the A index is pretty high. The A index is at 27. Okay. The aurora is going to be more pronounced now because as the A goes up, the aurora goes out. So it tends to go to a lower latitude, and people that like to work the aurora will do quite well when you start seeing really high A indexes coming in. Okay. But you also need to see that BZ latitude. And it's strange because if the BZ latitude is minus, it's going to be in the Northern Hemisphere where you have the aurora. If it's positive, it's going to be stronger in the Southern Hemisphere.
Okay. All right. Well, Larry,
Did I bore you to death, guys?
No,
No, that was great. Thank you, Larry.
No, yeah, definitely.
Great to hear the different indexes.
The check's in the mail, you guys. Just remember, the A is really important. It really is. Keep it under 10. The K, keep it under 3, and you're going to be really thrilled. And I admire all of you for doing what you're doing. Greg's a really good teacher. He's patient. You're going to learn a lot about CW, and I'm really proud of you guys for doing that. Kudos to all you guys. Thank you for what you're doing.
Well, thank you, Larry. Why don't you give a quick plug for your YouTube channel?
I do this weird YouTube show. It's for people who like radio. Really, it is. It is for people who like shortwave, ham, CB, AMDX. It's on every day at noon Pacific. And it really is a talk show about radio where people from all over the world come and just talk radio. It's a fun show. It's called Ham Radio Live. Love to meet you sometime.
Yeah, and he does it live.
Yeah, every show is live. I go by the seat of my pants and I pray to God that I don't rip them.
All right, Larry, thank you so much.
You're welcome, guys. You're welcome. Thanks for asking me, Mike.
We're on the path to getting better weather, so we'll get your antenna up soon, Larry.
Hey, no worries, man. Thank you. You be safe, all right? And guys, keep doing the good work. I appreciate what y'all are doing. Keep it up.
All right, thanks, Larry.
Goodbye, guys.